Hey guys, in this video let's learn how we can create a sparse matrix using NumPy library package. Now the first question that comes to anyone's mind is what is sparse matrix and why should I learn this? A sparse matrix is a mathematical object where I'm having the elements in a type of a matrix but most of the elements is equal to 0. And we have another type of matrix that is called as dense matrix where most of the elements are non-zero elements. Now, why this is important? The reason because whenever we are working with natural language processing or image data, we'll be dealing with these sparse matrices. Hence, it will be very important as a data scientist that you know as how you can create a sparse matrix and how you can work with this sparse matrices. So, let's see how we can create this sparse matrices first, and then at the end of this video, I'm going to share you as where and all that you will be coming across these sparse matrices while working with data science, machine learning and deep learning. So to get started, here I'm importing my NumPy library as NP, and to create a sparse matrices, we have a function inside my SciPy library that is called as sparse. Okay, so hence I'm importing my sparse and I'm importing my NumPy library. Now after the import, I'm just creating a matrix. So to create a matrix, in this scenario, I'm just mentioning it as list inside a list. Of course, we already have many inbuilt functions which are present in my NumPy library. I can make use of various inbuilt functions to create a matrix as well. But to keep it simple, here in this video, I'm just creating a two-dimensional array in the format of list inside a list. Now, once I create a matrix, if I want to convert it as a sparse matrix, we just have to send this matrix inside the function of CSR_matrix. Hence, in this example, I've created as matrix sparse is equal to sparse.csr_matrix, and inside the parenthesis, I'm just mentioning the matrix which I've just created. Okay, so let me just execute this, and if I now display my matrix sparse, see, it just has the representation as 1, 1 equal to 7, 2, 0 equal to 10. That means while printing the output, it is just displaying the non-zero elements. It's amazing, isn't it? Because if you look at it, if I just display my original matrix, so my original matrix looks like this. See, in my original matrix, most of the elements are equal to 0. And here in this scenario, some of the non-zero elements are only these non-zero elements. 7 and 10 are my non-zero elements and rest everything is equal to 0. And since these are not important to me, when I represent it as a sparse matrix format, and if I just display it as print matrix sparse, it is just going to represent as where and all my non-zero elements are present. Now, how does it help me? Let's consider this large matrix, guys. Okay, so this is a matrix large which I'm creating, and as you can see, this is a two-dimensional matrix as well. That means it's a two-dimensional array. It has rows and columns, and if you observe over here, I'm having most of my elements to be equal to 0, and only some of them are non-zero elements. Now on this matrix, I'm converting it to a sparse matrix using this CSR matrix function. Now once that has been done, I'm just printing out my original matrix, that is matrix sparse, as well as my matrix large. So let me just execute both of these cells. Okay, so let's observe this output, guys. Now this is my original matrix, and in this matrix, if you look at it, I just have a non-zero element over here that is 10, and another non-zero element over here that is 9, and another non-zero element over here that is 8. And as you can see, this matrix is of the shape. Let me just display the shape, guys, okay? Because that is very important, and that would actually give you the importance as why we are actually preferring this representation. See, this large matrix is having the shape as 3, 10. That means there are 30 elements in it. And out of 30 elements, I'm just having only 3 non-zero elements. That means if I'm trying to do any matrix operation, at that time, I'll be interested in only these non-zero elements because rest of the elements are equal to 0, and whether I perform matrix multiplication or whether I'm performing any matrix addition or taking any dot product or any such, so these 0 values does not add any importance for me. And even if I'm storing all these elements, so even while storing as well, it is going to consume a lot of memory, isn't it? Because it has to store it as a dense matrix format, and it has to remember each and every element that is present in that matrix. But by making use of this SciPy CSR matrix, that means by representing it as a sparse matrix, I'll be able to efficiently store in my memory. And along with efficient storage, it also gives me the advantage as where exactly are all these non-zero elements are present in this sparse matrix. Now here in this output, it says as there is a non-zero element at 0,6 and that is 10. This is that. And there is a non-zero element which is present at the index of 1,1, that is 9, that is this. And there is a non-zero element at the index position of 2,0, that is 8. Okay. Now, after we create it as a sparse matrix, there is a method called getNNZ, and this is going to return as how many elements are present in my sparse matrix. That means non-zero elements. So NNZ means get non-zero elements. And once I'm having my sparse matrix, if I want to convert it as a dense matrix, then at that time I can convert it with the help of toDense function. See, on this sparse matrix, I'm just calling this toDense method, and this would create me a dense matrix. Now in this way, we'll be able to create a sparse matrix and convert a sparse matrix into a dense matrix. The advantage that we would get when I'm working with sparse matrices, I'll be saving the space, and after I save the space, I can also get as where exactly are my non-zero elements are present, and with the help of this getNNZ method, I can get the number of non-zero elements that are present in this sparse matrix. As I promised already, I'm going to share you as where exactly that we'll be coming across this sparse matrices while working in the applications of data science, machine learning and deep learning. Now, while working with data science, machine learning and deep learning tasks, one of the common places that we'll be using this sparse matrices is whenever we are converting a specific data into a one-hot representation. An example can be is something as I'm having a user base and I'm just trying to mark it as whether this particular user has watched this movie or not. So in such scenarios, obviously, I'll have a large user base and I'll also have a movie name across the columns. And obviously not every user will watch all the movies that are in my database. So only some of it he'll be watching. Hence, we'll be ending up with a sparse matrix representation. And another example can be is number of listens of a song in a song playlist. Obviously, it applies the same concept that is over here. Not every user will listen to every song that is present in my playlist. So obviously, if I'm representing that particular data, I'll be ending up with a representation of a sparse matrix. And the key areas where we'll be using this sparse matrices is we'll be using in the area of natural language processing, recommender system, as well as my image data. Now, the way that we'll be ending up with the sparse matrices is, as I mentioned already, if I'm working with the task of natural language processing, I'll be definitely making use of one-hot representation. So with the help of one-hot representation, I'll be representing whether each word is present in my given sentences or not, and how can I represent that particular word. In such scenarios, obviously one-hot encoding will be used, or the other method that I could use is while working with NLP system is TF-IDF encoding, that is term frequency and inverse document frequency encoding. And also I can make use of count vector as a representation as well to mention as how many times that word or a particular word is being used in a sentence. And for the example of recommender system, you can consider the data that I have mentioned over here, with whether a particular user has watched a movie or not. And the same applies for my image data, where I want to represent given a blank image where exactly my pixel values are present. I hope this video has been helpful to you, and this gave you some insight about the sparse matrices which you'll be coming across in various applications while working with machine learning, deep learning and data science guys. Alright, so I'll see you in the next video. Till then, take care and subscribe to our channel for more such content.